First, we need to balance our equation. So we need to have the same number of atoms of each element on both sides, the react side and the product side. So we're going to label with the letter each compound. This is going to be A, B, C, D, and E. So for aluminum, we have 2 times A. 2 times A on this side. And the other side, you have 1. 1 times D equals to D. For oxygen, we have 3 atoms of oxygen times A. You have 1 more oxygen on this side, 1 times B, so plus B, is going to be equals to 1 atom of oxygen times E. Going to be equals to E. So on 4 to do with all elements. Then you're going to list the letters and give a number 1 to one of the letters. So let's say you're going to do 1 to A. If A is equals to 1, 2 times 1 is 2, that means D is going to be 2. If D is 2, 3 times 2, 6, B equals to 6. If D is 2, 6 times 2, 12, C is going to be 12. And to solve for E, you have B 6 plus C 12, 18. Divide by 2, 9. Just plug in your results. B is going to be 6, C is going to be 12, and then 2, and 9. And you have your equation balanced.
After balancing the equation, we convert our given kilograms to grams and then to moles of each compound. Then we use mole ratios to find our limited and excess reactants. So by just looking at these results, we can assume that these two are the excess because are bigger than this one.
The reaction stops when all of the aluminum oxide molecules have been consumed, therefore making it argons and reagents. We complete the multiplication and determine that we produce 325.62 moles of cryolites. If all of our 162.81 moles of aluminum oxide react. Once we have concluded that we can produce a maximum of 325.62 moles of cryolites, we will convert from moles to grams by using the molecular weight of cryolite. In this case, that would be 209.92 grams. However, our question is asking us for kilograms units. Therefore, we should convert from grams to kilograms by using our conversion factors. And then we obtain 68.35 kilograms of cryolite.
For this question, we're asked to find the total mass of excess reactants. Now, to solve this, we utilize the number of moles of aluminum oxide and we multiply it by the ratio of moles of NaOH to aluminum oxide. So we have 6 NaOH moles for every 1 mole of aluminum oxide. Therefore, when we multiply the 162.81 by 6, we get 976.86 moles of NaOH that actually reacted during this reaction. Now, we're going to do the same thing, but for HF now. So the ratio of HF to aluminum oxide is 12 to 1. So we're going to multiply 162.81 by 12, and we're going to get 1,953.7 moles of HF. Now, the number of moles that each compound has. So it's going to give us 407.86, and this 407.86, we're going to multiply it by the molecular weight of NaOH, which is 40.08 grams. Now, this is going to give us an answer in grams, but what we're looking for is something in kilograms. Therefore, we're going to multiply what we get by 0.001, which is 1,000 kilograms, 1,000 grams. And the answer we get from this is 16.32 kilograms of NaOH. Now, you could also have done it by dividing the value you get by 1,000. You're still going to get the same answer. Now, we're going to repeat the exact same process for the second one. We have two values, 16.31 and 16.32. Now, we're being asked for the total mass of the excess reactant. Therefore, we need to add both these masses to get the total mass of excess reactant. Therefore, when we add 16.32 plus 16.31, we get an answer of 32.63 kilograms of excess reactants during this reaction.